And as we start day number 2 here on the Archer, I just want to put out a very big thank you to Destry and to Jerry at Accurant for providing us a look at the NDT process when we do the AD for the wing attachments. So today we're going to finish up on the engine, do a compression test, and we're also going to check the timing for the Magnetos. So we have a couple more things that we're going to do as kind of a to-do, kind of like to-do type thing. Greg is going to replace the gasculator, and we need to also replace the mufflers because they're in pretty bad shape. So, we'll get some B-roll of that stuff, and we'll conclude day 2 here. And hopefully the next time we're doing filming, we're wrapping up the airplane and signing off the logbooks. This channel is about working on aircraft and flying those airplanes. So come take a seat and let's go for a flight. So this is the process we're using to calibrate the machine, is that correct?
Yes.
And this is you call that a standard?
Yes. Getting my signal over here to where it's in screen. I verify that I have a horizontal signal.
So these holes that are in the plate, what you call this the standard.
Yeah.
Do they already have defects in them, or is these?
This has little notches in the holes. You can kind of see a little notch there, little notch there, little notch there. Okay. I'll show you this big one for an example. It's got a notch all the way through. Yeah. It's a 30 thousandths deep into the material.
Right.
So that's what these are calibrated to, is a 30 thousandths deep.
So it's basically a predetermined defect.
Correct. Yes. No, that doesn't affect it at all. And this, I'm just let's see. I'll just go through the whole process of calibrating this again. So
these machines are quite sensitive, right?
They're less sensitive nowadays than they used to be. We still have to go through the same protocols as machines from yesteryear.
Right.
Simply because the ones from yesteryear, there's still a lot of those out there. So the procedure is still the same. But these hold their calibration a lot better.
Right.
Look, getting little wavies, but nothing that comes close to breaking the line. Actually, believe it or not, the meter display in Eddy Current machines, they didn't lose their cal at all. And then I'm running through here. I'm seeing a little bit of chatter as I go through. That's most likely the threads.
Yeah, I didn't get a chance to chase these with the bore brush yet. So if there's anything that's ugly that you're seeing, I can easily chase them.
Seeing anything? Nothing that remotely looks discerning. As long as it doesn't break my my signal gates, my alarm gates. Got a little something there that's close. And maybe that front one.
The front one?
Yeah, I mean it's not breaking the gate or anything, so it's fine.
But it's close.
Right.
So what? You kind of explain. You're an NDT inspector, correct? And what's involved to become an NDT? What kind of schooling do you have to go through?
I went to Spartan College of Aeronautics and Technology in Tulsa, Oklahoma. 12-month program.
Okay.
For the certificate. They also offer an AA, which gets you into QC/QA.
Okay.
So that's a 2-year program.
Right.
Transferable credits if you decide to go on to engineering or whatever.
Sure.
Yes.
Okay. And then so that gets you. So do you have what kind of testing do you have to go through to get that as well?
So the class involves training, lab training, and theory training in radiography, ultrasound, eddy current, magnetic particle, and liquid penetrant testing, along with visual testing.
Sure.
And
pretty inclusive for just about everything that you would need to use other than your eyeballs, basically.
Right.
Yeah.
And there are a handful of schools. Acuren owns a Hellier training that they do. There's Clover Park down in Tacoma. There's used to be called Hutchinson, now it's Ridgewater, I believe.
Right.
Up in Minnesota.
Okay.
Those are the ones that I know of. There's a couple others out there as well. They all specialize in NDT training.
Right. So in the Puget Sound area, how many NDT inspectors do you think that are doing these kinds of things just locally? Like a handful?
Yeah. It's just a handful.
And that's why
aside from the people that I work with at Boeing, that just work at Boeing.
Right, and are they under the Part 23, or did they had to go through the same stuff that you had to go through?
We all had to go through the same thing.
Same type of.
We all
kind of
had to go through
like an
school.
A&P does for his.
Correct. Exactly the same.
Okay.
It is very
But
specialized.
super specialized, and not too many people do it, basically.
Right. Sometimes some people get their training through the military. Military has NDT.
Yeah, and
schooling
that's
as well.
also the same way with A&Ps too. So,
Correct.
Yeah, there's a lot of transferable experience that you can use to authorize through the FAA.
And then once you get out of school, you have to get what they call OJT, or on-the-job training. So you have to accumulate a certain number of hours in every particular method before you can certify as a level 2 inspector in that method.
Okay.
And
then what about all the equipment? I mean, is this stuff that you own, or?
no, this is owned by the company that I'm doing the inspection here for.
I
Accurate
gotcha.
inspection.
Okay.
Bundle to deal with, but hopefully try not to kick you in the head. Try. Get on it. Ready? Okay. And then this one, I'm going to try and get from this side, because I can actually see it. That should be through.
Almost. See a couple threads through. There you go.
Okay. That easy. I'm gonna stick my head in your way, I'm sorry.
That's all right. Do what you gotta do.
All right, Greg, I'm on the front one. All right, here we go. That's good. Next.
I'm probably gonna feel this one a little bit more because it's spinning a little bit.
How was it?
Yeah. Couldn't quite get the pre-torque on it. Come around. Yeah, bring the socket around. There you go.
Oh, look at that. All right, go for it.
Grab a hold of it really good so it doesn't hit on that spar.
Got it.
Oh no, it's gonna go the other direction, right?
I got my 2 hands on. I feel them. Surprised this little 1/4-inch drive is big enough to take the...
Yeah, that's really the only thing you can get in there.
What's the torque value on here?
31 foot-pounds.
Oh.
Alright, to do a compression test, what we're going to need to do is take all the top cylinder spark plugs out, and then we need to find top dead center for the first cylinder. So first, to identify the cylinder on the Lycomings, it'll be on the co-pilot side front. You can also check the top of the case. We'll have numbers next to each one of the cylinders. What you want to do next is cover the hole for the spark plug with your thumb and pull the prop through with the mags off. And once you feel the pressure of the cylinder start pushing against your thumb, wait until you hear the mag click, and then that way you know you're really close to top dead center. Then we're going to install this adapter that's going to hook into our differential pressure gauge. So what we're going to do is we're going to pump 80 pounds of pressure into the cylinder and see how much of that 80 pounds it'll hold. So once we found top dead center for number 1, and we've installed the adapter plug, give it a little snuggy, and then we're going to hook up the air pressure, and hopefully the prop doesn't move, but if it does, hopefully you have somebody that can hold it that's strong enough. But either way, just stay out of the way of the prop. So first of all, I'm going to connect the pressure gauge up to the cylinder. Make sure this valve make sure the shutoff valve is off, and then I'm going to connect the air pressure and stand back a little ways, and then slowly increase the pressure. Another helpful tip when doing your compressions is knowing your firing order, because instead of trying to refine the top dead center for the next cylinder or jumping around, in the firing order you can just go to that one and then turn your prop that's the next cylinder to check. So you can find the firing order. Usually it'll be printed somewhere on the case, or obviously check your manuals. So the firing order on this here 360 Lycoming is number 3, which is just behind the number 1 cylinder. If you don't know, the odd cylinders are on one side, the even cylinders on the other. So once again, make sure the valve is off, connecting to the number 3 cylinder, and getting around the baffling. Shouldn't be that baffling. Now if you're getting a little bit of low pressure, or it's really bad, the way to check to figure out where the leak is at, because it's either going to come from the rings or some part of the valve train. If it's coming from the rings, you'll hear it if you open up your oil fill. You'll hear the air coming through there. That way you know you have bad rings. If you hear it coming through the carburetor, you know it's coming through the exhaust valve. And can also, if it's coming through your muffler, if you can hear it through there, then it's an exhaust valve. So if you're not careful and you apply pressure with the valve, you can actually get the prop to spin. So be careful when applying pressure and make sure nobody's in the way or somebody's holding the prop. I prefer not to have anybody around the prop. Now that the compression test is done, that's really not the only inspection that should be done on the aircraft. The only requirement is to do the compression test, but I have in here a very specialized tool that allows us to look inside the engine cylinders and the valves. So at the very end of this very long probe is a little tiny camera that emits also an LED light. The cool thing about this one is that the end of this, when you press this button here, you actually can look back at your valves. So this makes it very handy to be able to get a very visual look at the valve faces, and you can also crank open the valves a little bit so you can see the seats. The other advantage of it is that this will plug into either a cell phone or to another device, and I can actually capture pictures from it. So you can kind of keep a visual record of the condition of the inside of the engine, and that's probably more valuable than actually doing a compression test, because unlike a compression test really doesn't do a good job of an overall condition, because those pressures will change and over time they can come and go. So you could have a period of time where the aircraft doesn't fly much and you might see lower compressions, or if you're running it to lot and not leaning properly, then you can get deposits in there, and then maybe some of that stuff is sticking to the valves. So a really good indication of the condition is either by doing this boroscope or an oil analysis. But the oil analysis too, along with the compression test, is that it has to be done on a regular basis and have the airplane flying on a regular basis. I have neglected to actually show you guys how we verify the timing on the magnetos on the engine. So, as you may or may not know, the aircraft has two ignition sources, two magnetos, whether it be a regular magneto or electronic, but irregardless, it's going to have two sources of ignition. And with the Franklin, we've got two Bendix mags, and they are located behind the engine, behind the baffling, and right here is the starter. You got a magneto here, and then there's also a magneto just on the same position on the other side. What we have here, these are all of your spark plug wires that are going out to their respective spark plugs, and then this right here is the P-lead connection. This is what grounds your mags to keep them safe, to keep the coil from generating spark. So what we end up having to do is you have to come over and down in here, take out your number one spark plug, because this is the, I know my paint's peeling. That's the number one cylinder, because we need to be on top dead center of number one cylinder, which is that one right there. And then up here on the flange, this right here, you'll see some marks, and it's gonna be pretty tight to see, but up here, there will be some marks showing top dead center and then some numbers. We check to make sure that the crank is in the right position, and what we do is we verify that mark with the center line of the case. One thing I need to point out is that when you're checking this and you have an impulse coupling, and you know that because there's like this big burly piece of metal on the just on the inside of the gear, that impulse coupling delays the spark. So there's little flyweight arms that are inside that coupling, and at low speeds those arms come out and they delay when it actually trips the internals of the magneto. Once you're up to speed and everything is getting up to idle, and those arms centrifugally fold in, and then it proceeds to go back to its normal timing. An impulse coupling can change the timing up from about 20 to 25 degrees. And what that does is it delays the spark so that the piston gets further up on travel, so that when the ignition occurs, it actually helps it, as on a slower speed, travel back on the power stroke. And that's important because at higher power settings, if you had retarded timing, that could lead to detonation on all kinds of problems, because at higher power settings, that power stroke needs to be timed with the chemical reaction of the fuel actually burning is a little bit slower. So it needs to have that little time before top dead center, and that's why we always time, everything is always timed to top dead center. Airplanes don't have variable timing, so we set it to whatever the manufacturer deems is the most appropriate for the entire range, and especially at the higher power settings, so it doesn't detonate. And that's why we time everything to whatever before top dead center. What we have here is a buzz box or a synchronizer. And what this does is it checks when the magneto, the points, if you know how a magneto works, it's kind of like an old car where it's got points and condenser and all that. What happens is the magneto will build up a charge, and when the points open, it sends that charge from the primary to the secondary coil, and that's where you get your spark. When you're at your top dead center in your firing position, the points need to open. Well, this box right here can tell you when those points are opening, okay? So we're at top dead center. So there's gonna be 3 wires coming out of the back of this box. One is a ground, and you wanna hook that to something suitable that you know is gonna be a good ground. Then one lead goes to one mag, and then the other lead goes to the other mag, so that when you turn this on, and it makes a horrendous sound. Well, not right now, but when we pull the prop through, and we'll see this here in a second. So I've come back. So I'm way before top dead center. And what I'm gonna do is I'm just gonna start bumping this prop just ever so slightly, and every little bump is going to be a quarter, half of a degree, and you'll see it moving just ever so slightly, and then we're going to hear that box go off. There we go. See, they both came off at the same time. And the prop is in, I don't know if it's hard to tell, but the prop is definitely in a different position. Although you can't see it on camera. Trust me, that is at, I believe it's 30 or 32 degrees top dead center for the Franklin 165. So you should have your Franklin service manual. Yep. So for the 150 horse, so like the straights and the dash ones, we're 28 degrees before top dead center. And for the 165s, we're going to be at 32. And so I got a mark on the flange for where that 32 degrees is, and that's lined up right with the split of the case. Both mags are synchronized together and they're at their proper location, so we can put the plug back in. And one thing I did forget to mention is that you do need to turn the key on or disconnect the P leads to activate both of those magnetos so that they're hot. That's the only way you're gonna tell whether or not those points are open. So in summary, to check your mags, you're gonna put the engine at its either 28 or 32 degrees top dead center, before top dead center, and you're gonna hook up your box. Make sure that the key is on. I did forget to mention that. The key needs to be on, or your P leads need to be disconnected and make those mags hot. So don't forget to turn the key back off when you're done. And gonna connect up the box, turn it on, and then slowly move the prop back and forth and see where both of those mags are, the lights go out, and that will indicate when the points are open and when that mag will fire. Hopefully they're matched up together and should be at the desired specification, either 28 for the 150s or 32 for the 165s. But make sure you look that up in your manual, and as always, see you next time. So as I'm sitting here editing this, I just realized that I've left out a couple of, well, fairly important details. On the Lycoming 360, the timing indications are on the flywheel, and they're marked at 25 degrees before top dead center. And you'll see some the line on the front of the flywheel, and you'll match that up with a mark. It's like a little circle on the housing for the starter. And on some flywheels, there's actually a mark on the back of the flywheel as well, to where you can take a straight edge and align that with the split of the case. Other than that, you're finding top dead center on the number 1 cylinder, and you're timing your magnetos, except you have one impulse coupling on a lot of airplanes. The other one is actually deactivated during starting, so you're actually starting on one mag, and it's using that impulse coupling. So at the starting sequence, when you can still see the prop going through, you're actually firing almost right on top dead center, probably about 5 degrees, I believe. So another thing that I wanted to mention is that as pilots, we're using checklists, and as a mechanic doing an annual, a checklist. You're going to want to use a checklist. And this is one of the forms that I use, that I provide to my clients so that they have record of everything that was looked at, and everything that's on this checklist will be in that list that's in the FAR's Part 43, Appendix D. Also, I can also annotate any defects or make any notes about certain things that I find on the aircraft, and this is my communication with the owner-operator of the aircraft. So with that, we're just going to show you the engine run-up, and since this has happened like 9 months ago, that's how far behind I am. The signing of the logbooks has already taken place, and the airplane's flying and enjoying its life as an airplane. So we're going to go back to the video, and if you've made it this far, thank you so much. I appreciate it, and we'll see you on the next one.
Clear.
Alright, let's
Put her back.
put her back in. Well, we can do the cowl, but
You can do the bottom one, right?
bottom one, yeah. It's just that one.
Yeah, because it'll. By the time you guys are about ready to put the top on.
Yeah, you'll be back, so, yeah.
Yeah, in your condition, it's going to take us an hour to do that.
My condition. I'm not pregnant. Oh, parking brake's on. Sorry. Now, I'm not some rich and famous YouTuber asking you to like and subscribe to this channel. I'm an aviator asking you to like and subscribe to this channel, because that's the way YouTube works. If you don't click those buttons, YouTube doesn't know that you want to see more aviation content and won't show you more. But if you don't like what you've seen, please leave me a nasty comment down below, because that's the way the internet works. May all your flying be good flying. Da, 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 da.